Hello, I welcome you all to this wonderful lesson. And the topic for today, this is work, and this is lesson one. This is just one lesson, and lesson two, we are just going to see how to answer exam questions that do come in an exam. So I just want you to follow me clearly and attentively. The first question you need to have: what is work? You need to know what work is. So if you are told to define work, you need to understand that work is just defined as, so I'll say work is just what? Work is the product. This is the product. So I'll say this is the product of the force. This is the product of the force and the distance. This is the product of the force and the distance moved in the direction of the force. In the what? In the direction of the force. In the direction of the force. This is what you are supposed to know. This is something you need to understand. So when I say this is work, what I'm talking about is that this is the product of the force and the distance moved in the direction of the force. This is different to moment. Moment, we say that is the product of the force and its perpendicular distance. Moment is there if this is the distance moved and the force is in that manner and the force is coming that way. So if this is the force and this is a distance, meaning here there is what? Moment. But here, this work that we are talking about, we are saying that if force is moving in this direction, let's say this is a person here pushing this thing here. Have you seen? You are pushing something. Let's say a force is in that direction. This is force moving in this direction. So for us to have work, you need to make sure that there must be a distance that is being covered by the same what? By the same force. So there must be a distance here. This distance that this thing is going to move up to this particular point. Let's say you reach up to here like this. So meaning that if a force gets to move from this point to that other point, meaning there is a force that is changing, and the distance, force and distance, both of them are moving in the same direction. So meaning that there is work that is done. We say there is a what? There is a work done. So whenever you are having questions in an exam, you need to make sure that the force and the distance are in the same direction. So the distance should be in the direction of the force. That's when we get to have the work done. But for moment, it is different. The reason why I've brought moment here is because I don't want you to confuse the two. Because questions in this case, you are going to have work done. But whenever you've got something like this, there is no work that is going to be done. This is what you are supposed to understand. So don't confuse things. Moment and work done, don't confuse that. So work, you need to know and understand that work is a what? This one is a derived quantity. This is a derived what? Derived quantity. The SI unit is what? SI unit is what? The SI unit for the work is what? Is joules. So I'm going to say that is what? Joules. This is the SI unit for work. It is what? Joules. I do this. This is what you are supposed to know. So work done is measured in joules. Since I've told you to say that work is the product of the force, product of the force, product you are multiplying. So what I am doing is that work is a product of force, product of multiplying, and the what? And the distance. Where you know that F, that is the what? That is the force. Force is measured in what? Newtons. You also need to have, you've got W. W, that is the what? Work. So that one is work. Work, which is in what? Which is in joules. There is a D. D, that is the distance moved in the direction of the force. So that is what? Distance. I want you to understand this. Distance, I'm going to write it down so that you don't forget. Distance moved in the direction. Distance moved in the what? Direction of the force. So direction of the force. Direction of the force. And it is in what? In meters. This is what you are supposed to know. These are certain things that you have to understand. So I want you to know this. This is a simple lesson. This is a simple lecture that we are having this evening. Just wait. A simple lesson that you can't fail to answer, even a question that can come in an exam. This is something that is so simple. This is something that you can understand. Once I've given you a formula like this, you are able to calculate what? Work. You know that force, you know the formulas to use when the force is not given. These are simple things, and I guess you are able to work out questions that get to come in this manner. Let us look at an example. So in a case where you are having this particular question as an example. Hello, so these are 3 questions that I want us to look at. So let's see how we can answer these 3 questions. These are examples, so you get to expect questions of this kind in an exam. So I will answer these particular questions and see if we are able to relate with the few things that we've gathered. So I want you to know that everything that we've done, these things are interrelated. So don't say that, okay, we did forces. When we move to the other part, we need to forget everything about forces. No, these things are interrelated. So we say solutions. How can we answer these questions? The first one, a man pushes the big stone through 10 meters and exerts the force of 25 newtons. Find the work done by the man. You are told to find the work done by that man. How can you find the work done? So work done is equal to force times the distance. This distance is in the direction of the force. What is the force? 25 newtons. So I put 25 there times. What is the distance? The distance is 10. I put a 10 there. So meaning, what is the answer? If I multiply, I'm going to get what? 250 joules. So meaning that this is the answer. The work done is 250 joules. This is too simple, isn't it? As simple as that. Can we fail to answer that particular question? No, you can't fail. You can only fail if you are not connecting concepts. So it is just as simple as that. You know that a force is given, distance is there given. We now move on to the next question. Next question is saying, find the work done by a car of mass. You are given this mass of that car, 1000 kg. When it has accelerated 2 meters per second squared from rest in 20 seconds. You know that the formula is work done is equal to force times distance. You say this is equal to, what is the force? We are not given the force. We need to find the force. We know that the formula force is equal to mass times what? Acceleration. This is what we know. So what we are going to do, this is equal to, what is the mass? Mass is 1000 times, what is the acceleration? Acceleration is 2. So the answer is what? The answer is 2000 newtons. This is the one I'm going to put here. I'm going to say that the answer is what? 2000. So force is 2000 newtons. I put 2000 times the distance. How can I find the distance? So for me to find the distance, I know, okay, I'm given acceleration. I'm told that it is starting from rest, and I'm given this one that is there. So what I need to do here is to find what? Is to find now what I get to call distance using the formulas that we were using when we were doing 3 equations of linear motion. So remember that concept. There is this particular formula where I said x or displacement is equal to ut plus 1 over 2 at squared. There is this formula under 3 equations of linear motion. So these things, you are not supposed to throw them away. You get to use them right there and then. So when you are given initial velocity, have you seen initial? We are given this initial. If we were told that it started from rest. Time is given. Acceleration is given. So we are able to calculate the distance. Where I say this distance is equal, initial, it is 0. It is starting from rest. Multiplied by the time, which is 20. I do this. Plus half. Acceleration is 2. What is the time? 20 squared. This is what I'm going to do. We are doing what? Connecting concepts. So I say this is now equal to 0 times 20. That is 0. So 2 cancelled there. 20 squared, that is 400. Then I just say meters. So meaning this is the distance. So this is to tell you that those 3 equations of motion, you are supposed to understand them. You don't need to throw them away. Even as we get to advance, those 3 equations of linear motion, will be using them. The distance I've calculated, which is what? 400. So I put my 400 there. If I multiply here, I'm going to get 800,000. Then I say joules. Meaning this is the work done by the car. So this is what I need to do. Have you seen all these things that I've done? Force was not given, I calculate force. Distance was not given, I calculate distance. So we need to make sure that we understand all those ways that we can use in an exam to answer a particular question. So you just need to make sure that you know all these ways. I guess we have not forgotten the 3 equations of linear motion. All these, I guess you are able to write them in your book. 3 equations of linear motion. The first one was V is equal to U plus AT. This is the first one, where you know that this is the final velocity. This is initial velocity plus acceleration, that is time. Second one was V squared is equal to U squared plus 2AS. So these formulas, you need to know how to use them. So you need to make sure that you know how to apply them and how to use these particular equations. The last one is this one. So the S that is there, that is also the what? The distance. So if we were not given time in this particular question, but if we were given the final velocity, we would have used this and calculated for S. That is there. So X, I can say S or X. It is just one and the same. I can say S or X. It is just one and the same. Is equal to, you say UT plus 1 over 2 AT squared. These are what we call three equations of linear motion. So you need to make sure that you know all these things. So we've answered question number 2. This is question number 2. This is how you are supposed to answer it. I guess you are getting something here. This is how you need to answer these questions. We've answered that question. We move now to question number 3. How can we answer question 3? A crane lifts a car of mass 500 kg. This is already in its appropriate SI unit. No need of converting. Through 5 meters. Find work done by the crane. Work done is equal to force times distance. Work done is equal to force. Am I given the force? No. That's why I'm told G is equal to 10. I'm able to calculate force. Force is equal to mass times acceleration. If acceleration is not given, it can also work as gravity. So mass is 500 times 10. Then the answer we are getting is 5,000 newtons. So this is the what? This is the force. I put there 5,000 times the distance 5 meters. I put 5 there. So meaning that the answer is 25,000 joules. This is the work done. This is what you are supposed to do. The same way I'm answering these questions, this is the exact way that you are supposed to answer them. I'm just showing you how questions do come. So don't expect a question to be like straightforward. Every question requires a certain part of you where you are going to involve a certain thinking. So let's make sure that we know how to go about such questions. Everything we get to cover, you need to make sure that you know how to answer those questions. So let's make sure that we know how to go about certain questions. We know how to go about these things. So this is where we end from. This is where we get to end from. We shall continue. Thank you so much.